Hello, my dear students. This is Mr. Shaima Gharib and today's lesson about nets of the cuboid. Let's start by revising some rules before you watch any video. First, you have to sit in a quiet place. You should have your pen and a piece of paper to take notes and to solve the questions. You should pause the video after each question, then you try to answer on your own. Then you play the video to check your answer and to understand the question in case you get a wrong answer. Are you ready? Let's start. The cuboid has another name, which is rectangular prism, because it's a type of prisms. Let's answer these questions about the properties of the cuboid. The cuboid or the rectangular prism has how many faces? 6 faces. All of them are rectangles. It has how many edges? 12 edges, and the edge, as you know, the sides here are called edges. And how many vertices? And the vertices are the same as the corners. It has 8 vertices. This is the properties of the cuboid or the rectangular prism. Now let's talk about the net of the prism. I will show you the video for net of the cuboid.
This shape is called a rectangular prism. A rectangular prism has 6 faces, 12 edges, and 8 corners. It's very similar to the cube, except instead of all the faces being squares, they're rectangles. The opposite faces of a rectangular prism are always the same size.
Now, after the video, let's see the nets of the cuboid. In the video, we have seen that opposite faces are identical or are the same size. Look at this net. It has 4 identical rectangles, as you can see, and we have 2 sides with the same shape exactly, 2 identical sides or squares. So this net consists of 4 identical rectangles and 2 identical squares. Now look at this net. What is the difference between this net and this net? Look at these faces here. This face and this face are opposite to each other, and they have a different size than these 2 faces. Please remember the opposite faces don't meet at a side or a point. So for example, these 2 faces shouldn't be opposite, are not opposite to each other, because they meet at an edge here. So the opposite face of this face is this one, and the opposite for this one is this one, and the 2 sides are opposite to each other. So the difference here that this net has 6 rectangles, all of them are rectangles, but 3 pairs of opposite identical rectangles. As you can see, these 2 are the same, these 2 are the same, these 2 are the same. Now let's have some questions. Which of the figures below are nets of the cuboid? Look at the first 2 nets here. What do you think? As we said before, the net of the cuboid has 6 faces, and there will be opposite faces. Let's try to identify the opposite faces in the first net here. Look at this face. Can you find any opposite to this face? We said before, opposite faces should be same size. Can you find any face of these faces is same size as this one? No, that's why this is not a net of the cuboid. Cannot be a net of the cuboid. Look at the second one. We can identify the opposite faces as, we can say this face is opposite to this one, and this one is opposite to this one. What about these two, the two sides? Could these two faces be opposite to each other? No. Why? Because they meet at an edge here. And we said before that opposite faces don't meet at a side or even a point. So this one is also not a net of a cuboid. Now let's look at the net here and think, is it a net of a cuboid or not? Look at the opposite faces and find out. This one is opposite to this one, and this face is same size also and opposite to this one. We have four faces here are the same size exactly. Now look at the two sides. You have a square and another square. They are identical. And what most important about the net here, that look at this edge and this edge, they are the same length exactly. So this net is a cuboid. What about the second one here? What do you notice about these two faces? This one, if we said is opposite to this one, which is not true, then we will find that these two together, same size exactly, but they meet at a point and an edge, of course, a side here. Okay, so look at these two faces. They should be opposite to each other, but actually they are not opposite because they meet at an edge. So this one is not a cuboid. Now look at these two. What do you think? Look at the two sides here. They should be opposite to each other, but they are not opposite because they meet at an edge here. Now look at the last net. Let's identify the opposite sides. This one is opposite to this one. And this one is opposite to this one. And they are same size exactly. And this one is opposite to this one. So this one also could be a net for the cuboid. Now look at this question. We have two nets. Which of them could be a cuboid? What is the difference between these two nets? Actually, this net, the first net, is the correct net for the cuboid. Why this one is not correct? Because as we said before, look at this edge and this edge. In the net of the cuboid, these two must be same length. Look here, they are the same length exactly. If one of them is longer than the other, so this net couldn't be for a cuboid. Is this clear? So this information is really important when you identify nets of the cuboid or when you sketch a net for a cuboid. Pay attention to this side length and this side length, and also this one with this one and this one with this one. They should be the same. Now let's see a different type of questions about the cuboid. How many small cubes are there in this cuboid? As you can see, this cuboid has 4 layers of small cubes. Each layer, as you can see, has 9 small cubes. So I can just multiply the 9 by 4, 9 and 9 and 9 and 9. So it will be 36 small cubes, or I can use the rule of the volume of the cuboid. And as we said before, the volume of a cuboid equals length times width times height. The length here is 3 and the width is 3, and the height is 4. Look at the height here. Now, let's multiply. 3 times 3 equals 9, then times 4 equals 36. Now look at this question. What is the least number of small cubes needed to change this cube into cuboid? You have a cube here. It has 3 and 3 and 3. We need to change this cube into a cuboid. So I need to change one of the lengths I have. So we can add more cubes on top, one more layer, as you can see. So now I have a cuboid with length 3, width 3, and height 4. So all the small cubes I used here are 9 small cubes. This is the end of our lesson today. Thank you for watching and see you soon.